All right, folks, so starting at the top of page 3, how do I know this is a quadratic? Because it's degree 2. We've got our ax squared, r plus bx, and r plus c. So our a value for this one is what? Our a value is -1. So that means this is an end behavior going down graph. So it's a sad quadratic. Down, down, end behavior. And it looks like this. So leading coefficient is negative. It goes down and down. Our b value for this graph is 6. And our c value is -9. And what wonderful thing does that c value tell us? The y-intercept. Because if I plug in 0, 0 squared is 0, opposite of 0 is 0, plus 6 times 0 is 0, minus 9 is -9. So 0, -9, that's our first easy point to plot. That's down here. I almost did it positive again. So 0, -9. Do we know where our zeros or our x-intercepts are at? Nope. Don't know where they're at yet. So what's our next feature that we can find? The axis of symmetry. So I'm going to show my work off to the side here and say x equals -b over 2a. So -b would be -6 over 2 times my a value, which is -1. So -b over 2a. What's -6 divided by -2? 3. Plain old 3. But remember, your axis of symmetry is an equation for a vertical line. So it will be x equals 3. Let's go ahead and draw in that vex vertical line going through 3. Pew, 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 pew. So in order for this to be a sad graph, my vertex needs to be somewhere above this point so that I can curve down and be sad, curve down and be sad. Now we don't know if it's at 3, -4, or 3, +4, or 3, 10, or 3, -8. But what do we know about the x value? It's got to be 3. So your axis of symmetry, boop, always tells you the x part of your vertex. How do we find the y coordinate of our vertex? What are we going to do with 3? Plug it in. Plug it in where? To our equation for x. And folks, I'm going to zoom out a little bit here so we can see the whole thing. So we're going to plug the 3 into our equation. Now, folks, here's the real question. This negative that's in the equation, is that inside with the x or is it outside?
Inside. Outside.
It's outside because it's not in parentheses, so it's not getting squared. This is read as -1 times x squared. So if I want to plug 3 in, I'm going to show this work down below, f of 3. How we would type this in to our calculator is -3 squared plus 6 times 3 and then -9. It's a little strange that before we're like, hey, make sure you have those negatives in parentheses. That's when you're plugging in a negative x value. This, I'm not plugging in a negative input. This negative is outside of the input in our equation. So it's got to be outside the parentheses when we're plugging in a value. So folks, let's go ahead and type this turkey in. Little negative, parentheses, 3 squared, arrow over to escape the exponent, plus 6 times 3 minus 9. And we get 0. All right, so it said 3, 0. So f of 3 equals 0. So boom-a-loom. There's our vertex. If our vertex is at 3, 0, what have we also just found? The x-intercept. And how many are there? Only 1, because it is the vertex. And this makes sense because when there's only 1, it's going to bounce at that vertex point. So R0 is the same as our vertex. So we would say x equals 3. So x-intercept, number, and 0. All right, folks, so we need some more points to know exactly what this graph looks like. So where do I want to make this table? Let's go ahead and make it up here. I am making it obnoxiously long, even though I don't really need to do that for this one because I've already got the x-intercepts captured by that vertex. So I really am just going to do 5 points. So my vertex is 3, 0. That's what I'm going to use for my center point in my table. I'm going to go a couple x values below, 2, 1, and a couple x values above, 4, 5. Now, if you did what you were supposed to do and practice typing that in, now we should be able to just do second enter and override the 3 with a 1 to give me -4. Second enter again, override those 1s with 2s. That gives me -1. Now, what should 4 give me as an output? It should give me -1. Am I just going to assume that and go, yep, we'll just put -1 there? Folks, do not make any assumptions. I know I'm doing this problem, so you're like, oh gosh, if Mrs. Cairo made a mistake, then we're kind of in trouble on this problem. But it's better to not assume, because if your vertex is wrong, this is how you will catch it. A lot of times where students will goof is little dumb things with the signs, like right here, they'll say, oh, that's a -3 instead of a +3. So if you had your vertex as -3, what would happen is your table would not give you symmetric y values around the vertex. So I don't recommend it. Always check at least one of those values to make sure you've got symmetry. Boom, -1. That is good. So what is 5 going to give me? -4. There's our lovely symmetry. And we've already found our x-intercept, so that's all we need to plot this parabola. So 2, -1, 3, 0, 4, -1, 5, -4, and then 1, -4. And don't forget to hit our lovely y-intercept that we have down there as our extra point. And make sure you've got your arrows on the end. How are we doing so far? See if you can answer the next 3 questions. State the end behavior, what's the domain, and how do we state the range? Go. Since this is a sad graph, my end behavior is going down and down because of that negative leading coefficient. So f of x goes towards negative infinity, and f of x goes towards negative infinity. So we look to the left, we look to the right, and the function goes down towards negative infinity on both ends. My domain is all real numbers, or negative infinity to infinity. And folks, you don't have to write both of those. Pick one. R is a little bit easier to write, but again, if you're looking to take pre-calc, getting that end behavior notation practice is good. And then our range is y less than or equal to what?
0.
0, thank you. Sometimes students will put 3 for this one, but the place where my y values start is actually at 0. So y less than or equal to 0. If you wanted to do interval notation, it would be negative infinity to, whoops, and there I wrote 3 because I was talking about 3, 0 with a bracket. Naughty. So negative infinity to 0 with a bracket. This whiteout is absolutely disgusting. Nothing like chunky whiteout to ruin your day. All right, folks, how are we doing so far with questions? Lots of things that are similar to the last unit. Big things that are different are the axis of symmetry and using our calculator to generate the table. Folks, you're going to want to check very carefully on the answer key with these. So making sure you are checking those exact points because a lot of the mistakes happen in here on your calculator with little negatives versus big negatives and with your parentheses. So folks, let's go ahead and take a look at this next problem and see what we know. We've got an A value of 1. So A value is 1. Positive leading coefficient means our graph is going up and up for the end behavior. Is happy. So folks, just to show you, you don't have to do these steps in like a specific order. If I go, hey, while I'm thinking of the end behavior, I'm going to go down here and write it, you can. As x goes towards negative infinity, f of x goes towards infinity, positive infinity. And as x goes towards positive infinity, f of x goes towards positive infinity. It's going up and up on both sides. What's my domain? All real numbers again. Always all real numbers for our quadratics. But can we do the range right now? No, because we don't know where our y values are going to start because we don't know the vertex. So you can jump around with some of these key features, but not all of them. A sequence that has to be in place is the axis of symmetry, then the vertex, then the range, because those three things are dependent on each other. So folks, I'm going to turn you loose on those first 2 steps. See if you can find, well actually let's do the y-intercept first. What is our y-intercept for this one? It's 4. Writing that as a coordinate 0, 4. So remember, your c value tells you the y-intercept. So plunk, there's my y-intercept right at 4. So our c value is 4. Our b value is negative 6. So I'm going to give you a couple of minutes. See if you can find the axis of symmetry using that equation that we're starting to get in our brains for memorization and finding the vertex. Good luck. symmetry. Not just 3. X equals 3. Very, very, very important because your axis of symmetry is not a value. It's an equation for the vertical line. So, folks, I'm going to keep stressing that over the next few days, that it has to have that X equals with it. Your vertex, when you plug it in, you didn't need to put in parentheses here because 3 is positive. But when you plug that in, you should get an output of -5. So my vertex is at 3, -5, and my axis of symmetry goes through 3. Raise your hand if you got both of those parts right. All right, good. We're going to keep practicing. We're going to keep working on these. At this point, do we know what our range is? Yeah, if this is a happy graph, we start at the y value and are covered going up. So y is greater than or equal to -5 or bracket -5 to infinity. Now, this one is a little bit tricky because of the zeros. I want you to put a star by the zeros. Does it look like my graph is going to hit the x-axis? Yeah, because if this is my vertex and I have to curve up to that y-intercept, I'm definitely going to hit the x-axis. So I'm going to make a large table centered around my vertex at 3, -5. And I'm going to go a few x values below, 2, 1. A few x values above, 4 and 5. And I already had my vertex work in my calculator, so second enter. Override those 3's with 1's. And I get -1. Is that an x-intercept? Nope, it's not a number in 0, so not an x-intercept. Second enter, I'm going to override those 1's with 2's. And we get -4. That's not an x-intercept either. Now, what should 4 give me for an output? It should give me -4, but I'm not going to trust myself. I'm going to put in 4 just to make sure. And whew, we get -4. And once I've proved it for 1, I'm going to assume that that's going to be -1 as well. So that's 5 points. Let's see what that gets me. 1, -1. 2, -4. 4, -4. And 5, -1. Have we hit the x-axis yet with our table? Not yet. So we're going to go 1 more point below and 1 more point over here. What am I going to get when I plug in 0? The y-intercept, 4. Whoa, okay. So we got 4 there, which means we're going to have to get 4 here. That's the y-intercept. Is it also the x-intercept? No, it's not a number in 0. So I'm looking at the points I have, and it looks like my graph has crossed the x-axis. Swoosh through those points. Have we definitely crossed the x-axis? Yep, definitely crossed the x-axis. But did we cross at a nice integer value? No, we did not. So, folks, this is why solving for the x-intercepts by graphing is not always our best method. First, we hate graphing. I know that. We never really like graphing anyway. But also, if we have a fractional x-intercept, graphing is not very efficient. Now, we could get crazy and say, well, I'm going to try to plug in 0.5 squared. Or actually, yeah, 0.5 squared. And then minus 6 times 0.5 plus 4. That gives me 1.25. Folks, how many decimals are there between 0 and 1? Oh, you know, an infinite amount. No big deal. So, I mean, we could just keep plugging in decimal numbers and try to find the x-intercept. But graphing is not going to get us there. So here's what we're going to say about these zeros. Somewhere between these two values, so somewhere between +4 and -1, I got 0. If here's -1, here's +4, somewhere in between those we got 0, which means somewhere in between these two values we had an x-intercept. Same with down here. Somewhere between -1 and 4, we hit that output of 0 that we want, which means somewhere in between those two values, we hit our x-intercept. So your x-intercept, remember, is a number in 0. So where I go from a +4 to a -1, somewhere between that positive and negative, I cross the x-axis. Here's +4, here's -1, there's where the 0 would be. Here's +4, here's -1, somewhere in between those is my 0. We can also kind of tell from the tick marks on our graph that my x-intercept is somewhere between 0 and 1 and between 5 and 6. So that's how we are going to write our answer. X is between 0 and 1 and 5 and 6. And we're going to do more work with these tomorrow. So no work done. You can start on the homework if you want. The first page isn't due until tomorrow night, and we should have some work time tomorrow. Some new stuff, some old stuff, but folks, practicing on your calculator is going to be key for this. It's so easy to just copy down the tables or just copy down the points from Mrs. Cairo's answer key. But this, being able to use your calculator, is going to come back to haunt you in future chapters, so we need to make sure that we know how to type stuff in correctly.